this Turing machine. So the definition, the attributes of Turing machine is it is having 7 attributes. This is a set of states. Using input alphabet, tape alphabet, transition function, okay. This is 7 attributes. Actually, Turing machine, it's look like an infinite tape. So it is having a blank space inside the tape like this. You are having a lot of blank spaces. If you are going to load the input symbol, you can store inside this tape. After that, you have to recognize whether your symbol is available in your Turing machine. So it is also going to give either accepted or rejected. Your output may be of accepted or rejected format. Okay, we'll see one example for this Turing machine. For example, design a Turing machine to implement f of x is equal to x plus 2. You take assumption your x value is equal to something. So the input tape of this function is 3 now. So you can take it as, we cannot store directly 3 into Turing machine, but I can take it as zeros and ones I can store in Turing machine. So 3 means we can take it as 3 zeros or 3 ones. So I'm going to consider ones. So 1, 2 ones, 3 ones. Before and after of these ones, you can give a blank. Okay. Your head pointer is available in the first input symbol. Where your input is started, in that place, the first position your head pointer will be placed. Now, what is the output tape will be there? So this is my input. This alone is your input. Okay, the output should be of x plus 2. So 5 plus 2, already x value is 3. So 3 plus 2 is 5. So how many ones you have to replace? So 5 ones. 1, 2, 3, 4, 5. So before and after we can place a blank. It's very simple. Already 3 ones are available. You have to place only extra 2 more ones. So what I have to do? So you can read all the symbols, okay, till you reach a blank. After reaching here, change this one blank into 1. Take 1 more blank space. That is also you can change 1. Then you'll get a 5 ones. Actually, so you know that the 7 attribute is, so you are having the previously set of states, input symbol, tape alphabet. Okay, the tape alphabet in the sense this is what are the symbols you are have stored in your Turing machine that you have to store in this attribute. Okay, and one more is you know that initial state already, final state is also we already studied in finite automata. Blank spaces is for this symbol. Okay, available symbol in the Turing machine. So one more is we are having transition function, right? So how we can represent a transition function for Turing machine is, so the state you have to take it. Okay, you want to move from one state to another state. The transition is represented as state followed by the symbol available in the Turing machine. Wherever head pointer is pointed, that I have to represent here. For example, you take it as X, you take as a machine. The output should be of, it should go another one state, no? So I can take it as Q1. And this X is already available in the tape. If you want to change the symbol as different symbol, that is also possible. Otherwise, you can use the same symbol also. Okay, just I want to read that symbol, just I want to move to the next question now. You take the same symbol. Otherwise, I don't want to change the symbol. I want to change the symbol means I can give it as Y also. And you move a head pointer also, right? After changing of this symbol, you move a head pointer to the next position or a previous position. So I can move my head pointer to the right direction or a left direction. All possibilities there. So here you can give it as a direction. Okay. Like this only how to represent the Turing transition function of Turing machine. Now you consider this one. So I'll draw the diagram first. I'll take it initial state. Your head pointer is here. How can you represent the H value is you are in Q0 state. What is the symbol available in the Turing machine? Wherever head pointer is initially pointed, 1, right? That you can take it. Slash. If you want to change this symbol, you can give here. Suppose I don't want to change the symbol now, I can take it as same symbol. Here, this X is 1, this Y is also 1. This symbol is not at all changed, right? 1, I have represented the same one only. So after reading of this symbol, I want to move to the next position. Then you can give a right direction like this you can represent. Either you can give like this, otherwise you can give a on. Now my head pointer is in the second one. Okay, how many ones you are having like that? This is I have taken X value is equal to 3. You can also take your X value as 100. You can also take your X value as 1000. So for this particular one is already recognized using this straight line. Remaining ones also you have to recognize till you reach a blank symbol. Then suppose if your symbol is your X value is having 100 means we cannot use a 100 state, right? That situation, one alone I used a straight line. Remaining 99 ones I'm going to use a self loop. The same thing, right? I don't want to change that one. Just move a head pointer to the right direction. Now all the symbol is recognized. It will goes to where means the blank symbol. Now you can start here. Use one more state. Change that first blank symbol into 1 because 2 more ones you have to include. That is only our constraint. So I can change that first blank symbol into 1, move to right direction. Now this symbol is changed as 1. The next symbol also you have to change 1, right? So I'll move from here another one state. The next blank is also I can change into. You can close your diagram also. Now this is also changed as well. You check it, where X value is 3. What is your output? 5. That is only we have to do. Yeah? So this is only that output of this X plus 2. So this is like that. They will ask any question. Suppose they'll ask question as an implement a Turing machine for the function f of x is equal to x plus 1 means only one blank space you have to change into 1. Suppose x plus 4 means how many blank spaces you have to change as 1? 4 blank spaces. Okay. So this is one concept. So after drawing, what are all the attributes, what are all the definitions you have to write for implementation of Turing machine is, first one is this diagram. Okay, transition diagram. Next one is I have to fill the attributes also. So the first attribute set of states, right? So our attribute set of states, input symbol, tape alphabet, transition function, initial state, blank space, final state. This is only one definition. So fill all the attributes, all 7 attributes. So state is you are having Q0, Q1, Q2 and Q3. What is the input symbol? Here is I represented my x value as only 1, right? So input symbol is. What is a tape symbol? You check in the tape. Okay. What is the symbol available that I have to take it? One is the already by default blank symbol is there, followed by 1. Transition function I will write later. Initial state is also Q0 here. Blank space is represented as B only. Final state of this problem is Q3. That's it. Okay, after that you write the transition function also. The transition of you start from Q0. So Q0, what is the first symbol you are recognized in Q0? 1. What is the output for this one is where it is go? Q1, right? Q1, comma. What is the changing of your one is? There's no change, same symbol, right? So I can take it as 1. What is the direction here mentioned? Right direction. So I can put it like this. Only one transition is there for Q0, that is over. You take for another state Q1, how many transitions is there for Q1? Actually, one is self loop, another one is a sprite line. First, I will write a self loop transition function. So Q1 comma 1 is equal to where it is going Q1 only, right? So Q1. What is the changing of that symbol? There is no change. Same symbol, so 1. What is the direction? Right direction. Okay. What is the one more transition function for Q1 is the straight line, right? What is the symbol? Blank. Input symbol is blank. Where it is going? Q2. What is the changes? 1. What is the direction? Right direction. So next, we can take it as a Q2 state. So here is also, it is recognizing blank space. Where it is going? Q3. The blank is changed as 1. The direction is 3. There is no move for Q3 state. Then we can leave it. Only 4 transition function for this state machine. Yeah. So this is one problem. Another one is, we can give the odd and even numbers. Design a Turing machine for the language L is equal to 1 power n such that n is odd number. Okay. So in the sense, it should recognize single one, triple one, 5 ones, 7 ones, like that. The Turing machine is having maybe of 3 ones. What I have to do? Whether your machine recognized only odd numbers. Okay. So I'll take it an initial state to not. First single one only. Okay. For that we can draw the diagram. After that we can include the 3 ones, 5 ones, 7 ones also. So first I'll take it as Q1. Okay. From this, 1 is I don't want to change that one. Just I'll put it as a 1 alone. Otherwise, if you want to change means you can give blank also. Just move to right. Then you consider this state as a final state. I'm going to give blank after recognizing of a single one. Sure, you are having blank space. So blank, blank, you can stop the process. You consider this is a Q2 state. A single one is recognized. So this is a diagram for single one. Suppose I want to recognize the 3 ones. So single one. So again, you can give where I have to give a control from Q1 to I can give Q0. Because I want to read one more one, second one and third one. So 1, change this 1 into blank space. Again, from here to here, it will be taken as a third one. So 1 can be changed into blank, move to right hand side. So after the third one, sure you are having blank space, it will goes to the final state. You consider this diagram. So we have to start with the initial state Q0. The first one is changed as blank. Then move to right here. You are in Q1 state. It will check whether you are having a 1 or blank space because Q transition is there for Q1. So after first one is changed as blank, you are having 1 only. So it will go from Q1 to Q0. So this one changed to blank space. Again, it will move to the right hand side. Now you are in Q0 state. So you are having only one transition. The one symbol change this blank. So this is change this. Now you are in Q1 state. The head pointer is in blank space. So if it is there means it will go to directly final state. This is n value is a odd number. Sometimes the last question is 0 power n such that n is odd. What I have to consider? Instead of 1, you have to give it a 0. That's it. Your input is zeros. Okay. So for one more question is L is equal to 1 power n such that n is even number. Okay, actually it's very simple. The same diagram, only thing is which particular state you are going to consider as a final state. That I have to think. Even number is maybe of 0, 2, 4, 6. This is only even numbers. 0, how can I represent in FLA? So we'll give it as an empty string. So for 2's meaning is 2 ones. 4 is 4 ones. 6 is 6 ones. Your automata, empty string is we know that. Without reading any input symbol, your control goes to final state. I can call that as an empty string, right? Here is also, I am going to take a same representation. Q1. So 1 is changed this. Blank. Move to right. The same thing. Okay. Whatever we learned in odd number, this is I'm going to take. So empty string is, this is the beginning itself. It will goes to final state means I can consider the empty string is recognized. So from initial to directly I'm going to give one final state. Okay. Here, without reading any input symbol, sure, what is the symbol available in Turing machine? Blank space. So blank space, right hand side. Okay, now this is accepted. So 2 ones is from Q0 to transition. One is blank, another one is 1. So it will goes here. So the first one is changed this blank. From Q1 to Q0, another one is also changed as blank. Finally, we are in Q0 state, so it will go to final state. 4 number of ones means 1, 2, 3, 4. Now you are in Q0 state, it will go directly final state. Clear? So after draw this diagram, you have to write the Turing machine definition, the attributes, values, and transition function also you have to write. Okay. Sometime they'll give a input string, you have to check whether the input string is accepted or not. That is also you have to write it. So 3 things you have to write for all the Turing machine problem. One is the diagram, okay, transition diagram. Second one is you have to write the attributes. Turing machine definition you have to write. Third will be called as you have to check whether the string is accepted. Instantaneous display. ID, I can call it as a ID. For example, take this problem. I want to check the string 2, 1, whether this is accepted or not. Okay, how can I start the problem is, you start it with initial state. Then you can fill your input string 2, 1. After that, you can fill blank space. Before the state also, you can fill the blank space. Okay. Now, you have to check Q0 with the first input symbol. Q0, comma, what is the symbol you are having? 1. Yes, Q0, comma, 1 is there. What I have to do? So, change this 1 into blank space and what is the state changed? Q1. And what is the direction you are having? Right direction. It's very simple. So you have to right direction means one symbol ahead. So your Q0 should be placed here. Okay. How it is changed? The Q0 is changed as Q1 using this transition. And this 1 is also changed as blank space. So the transformation of this particular sequence to already this blank is there, that I'll write it here. Then this 1 is changed as blank, that I'll write one more blank. Then the Q0 is changed as Q1, right? So I can write this Q. What is the balance symbol we are having? One blank space. Here is also Q1 comma 1 you have to check it. Is Q1 comma 1 you are having, right? So what is the direction you are having? Right. So this particular head pointer is move to one symbol ahead. What is the changed state? Q1 comma 1 is Q0. So that place you have to fill Q0. And change this 1 as a blank symbol. Okay, so already 2 blank is there before this Q1. Followed by this 1 is also I'm going to change blank. So blank space. What is the state changes? Q0. So Q0. Followed by you are having a blank space. So Q0 comma blank space, it will goes to final state. Okay. So these three, this is an ID. You take any example, you have to, now you check out Q0 comma blank space, where it will goes? Actually, final state. So here you can write it as 3 blank space. This is also no change, right? The last blank space is no change. Just move to right hand side. What is the state you are having? Q2. Okay. This is actually final state, right? Q2. So the given string is X. Like that you have to write. Clear? So totally, so 3 things you have to write for all the Turing machine design.